Howdy students. So we've been talking about Sig Figs. Now we're going to really, instead of just using those measurements that we've been taking, we're going to start working with them, because you don't just take measurements for taking measurements. You want to do some calculations, you want to do some analysis. So you may even want to figure out what you're going to add together. So let's figure out how to work with those. So you can't figure out Sig Figs from calculators, because let's imagine we measured on a balance 22.0 grams divided by 7 mLs. Well, that would come to 3.142857143, depending on how good your calculator is. And you may want to know, should we write all these numbers down? Well, you can, but that's really not accurate. You don't want to lie. You want to give good information about what your precision is. So what you can figure out is you can look, okay, here 22.0 grams and 7 mLs. Well, the 22.0 we can see has 3 Sig Figs, and the 7 has just 1 Sig Fig. And you could probably guess, okay, well, we're going to be limited by that 7. In fact, yeah, if there's only one significant figure, the answer really is just 3. And that's because we are limited by our one significant figure. We're going to do more examples, don't worry. All the numbers aren't necessary. If you don't write enough numbers, that doesn't tell you how much precision there is. So let's figure out, again, exactly how to do that. So with multiplication division, you count the number of Sig Figs in each value like we did, then you do the operations, then round to the answer to have the same number of Sig Figs as the number with the smallest number of Sig Figs from one of them. So if we multiply 20.4 times 17.32, we see this has 1. We see the dot is here, so we're going to start here. We have 1, 2, 3 Sig Figs. 3 Sig Figs. I'm not even going to write Sig Figs, you guys get it. And this one, we start here, we hit the 1, 1, 2, 3, 4 Sig Figs. But when we jam in our calculator, we get 353.328. Okay, well, we know we can only have 3 Sig Figs, so we know it's only these 353 with the dot. That is an accurate number of Sig Figs with these, multiplying these two numbers together, if these are both measurements. How about addition and subtraction? Well, the answer cannot be more precise than the least precise value. So this time you find the Sig Fig place value in each number, do the operations, and then round to the place of the least significance from step 1 relative to the decimal point. So for example, we have 20.4 plus 17.3269. And when we jam that in our calculator, we get 37.7269. Well, again, we are limited, and again, not by the Sig Figs, but by the place. This has a lot more precision. This is our limiter here, because it has the least amount of precision. It just goes to the 10th. So our answer has to be 37.7. We're going to round because of this is the 10th place. 37.7 is going to be what we round to. Because this is a 2, we don't round up, so we just have 37.7. Let's do one more example. If we had 0.0023 plus 4.12, if we jam that in our calculator, it's pretty easy. We'd get 4.123. However, because these are measurements, we should have values here, so we'll say this is grams, or units here, this is grams, this would be grams, but this is a lie because this here is the limit. This used a better machine than this did, so this is going to limit us here, just like our econo balances and things that we looked at earlier. So we know that we are limited here, so the actual measurement, because we only measured using a balance that would give us this much precision, comes to 4.12 grams. So that's going to take a little bit of practice for us to use. You're going to have to think at the end where the place value is after the digits, after the decimal point, instead of the sig figures. But we'll get you some practice here so you guys will be great at it. The only other thing that I want to do is tell you about our buddy Lord Kelvin and his scale. So he worked at determining absolute zero because he knew that absolute zero, that's the lowest value temperature could possibly go, is when all kinetic energy is removed to the system, because temperature is a measurement of the amount of kinetic energy in the system. So when all of it is removed, it's negative 273.15 Celsius. So Kelvin, the number of Kelvin is just the degrees Celsius plus 273.15, because absolute zero is negative 273.15 degrees C, and that equals 0 Kelvin. Just another quick little thing to know. Memorize this computation because we're going to be using it frequently in different laws. You have to work with Kelvin, not with Celsius, so we're going to get good at it. So that's what I'm going to leave you with. I hope that was helpful. Have a great one.